First lecture I'm doing in statistics, and I'll be doing the June 2011 question paper 6 variant 2. And we're going to be doing the first question. And our first question says a bias die was thrown 20 times and the number of fives was noted. The experiment was repeated many times and the average number of fives, or the mean number of fives, was 4.8. Find the probability that the next 20 throws, the number of fives in the next 20 throws will be less than 3. So that means the number of fives can be either 0, 1 or 2. We can recognize immediately that this is a binomial distribution problem. And how do we do that? Well, there are a few properties to note. One, there's a fixed number of trials. And in this case, the fixed number of trials is 20. We can denote these fixed number of trials by a variable n and call it 20. Second, the event that we're talking about is either a success or a failure. And we have a probability of success P and probability of failure Q. So we can find these two. Now, our first step in this problem is to find our probability of success and failure, and we can use a simple formula. If we have the mean number of fives that we've got, in this case, the probability of success is basically the probability of getting a 5. Success is just basically the probability of getting a 5. And a failure is probability of not getting a 5, not a 5. Now, if we have the mean number of fives, in this case it's 4.8, we can use a formula that is the number of trials n into the probability of success p is equal to our mean, which is 4.8. So we have 20 into p is equal to 4.8, and we have probability of success, that's probability of getting a 5, equal to 4.8 divided by 20 equal to 0.24. And we know that the probability of failure Q plus the probability of success P, since there are only two choices, is equal to 1. So therefore, our probability of failure Q is equal to 1 minus 0.24, or 1 minus P, which is equal to 0.76. I'm going to clear this page. I hope you got this down. We're going to be using this for later problems, this and this, for later problems. So I'm going to keep this here. Now, to apply the binomial distribution, this is a simple formula to use. The formula is NCR Q to the power of n minus r, P to the power of r. Now in this case, r is the number of successful events that we want. So r is the number of successful events that we want. Now, so in this case, when they say find the probability of the number of fives being less than 3, the number of fives could be either 0, 1 or 2. So we need to find the probability first that there are 0 fives in the 20 trials. Then we have to find the probability that when there's only 1 5 in the 20 trials. Then we have to find out the probability when there are 2 5s in the 20 rolls or the trials. So this is this or this or this. So if we apply this formula, we know our first one will be 20, that's the number of trials, C 0, because R is equal to 0, we want 0 5s, assume that it's 0 5s. Q in this case is 0.76 as we found earlier over here, to the power of n minus r, 20, into P is 0.24 to the power of r, 0. And this is equal to just 0.76 to the power of 20, which is equal to 4.13 into 10 to the power of minus 3. Now I'm keeping this in three significant figures, so you can use more if you want. So this number we would need for later, so I'm going to be keeping this. Now since we have both of these in our memory, I'm going to clear this page. So now we want to find the probability that the number of 5s is equal to 1. That is, R is equal to 1. Number of 5s in that 20 trials is equal to 1. So 1 5 is coming in those 20 trials. So we can use 20C1 NCR, R equal to 1, 0.76 to the power of n minus 1, n minus R, which is 20 minus 1, 19, into P, which is 0.24, into the to the power of 1. And this is equal to 0.76 to the power of 19 into 0.24 to the power of 1 into 20C1. And this is equal to 0.026. I'm doing this to three significant figures again. We would need this, so we're going to keep this. Next, we want to find the probability that there are 2 5s. So we will have 20 C2, 0.76 to the power of 18, this is the same, into 0.24 to the power of 2. And this is equal to, if we calculate this, we get this to the power of 18 into 0.24 to the power of 2 into 20C2, which is 0.078. So that means there's a 0.078 probability of getting 2 5s in that 20 trials. Now, since we want the probability of the number of 5s being less than 3, that is 0 or 1 or 2, the OR tells us that we have to add these three probabilities. If we had an AND, that is 0 and 1 and 2, we would multiply these three probabilities. So doing that, we would get 0.078 plus 0.026 plus 4.13 into 10 to the power of minus 3. And this is equal to 0.108, which is equal to 0.108 or 0.11. And that should be our final answer. I hope you understood how I got this. The probability distribution is the concept of probability distribution is easy to understand, but it's difficult to know when to apply this concept. There are certain keywords in the problem that will tell you this, but it'll come only mainly out of practice. Make sure you practice many papers, then you'll understand how the probability distribution works and and when to apply the probability distribution. Usually find two things: a fixed number of trials and either a success or a failure. In this case, the fixed number of trials was 20 and the success was getting a 5 and the failure was not getting a 5. Averages can be given to you, so you can use that nice formula. NP is equal to the mean or the average. And I'll be discussing more formulas with you in the next lecture.